Okay, good evening everyone to another nice, calm, clear winter night in Eastern California in the Death Valley region. My name is Mike Jerry and got a little bit of a different show tonight. We're going to do a show with the narrowband filters, so we're going to look at a lot of emission nebula tonight and spend a little more time on each object because the filter blocks out a lot of the light of other stuff, so it takes longer to actually get our images. But the results are some pretty fantastic stuff, so I think you'll like what we've got. Okay, the first thing I should do, as always, is to show you my setup. So, let me turn off the test pattern and show you what I'm using tonight, which is a Celestron 8-inch Schmidt-Cassegrain telescope here with a Hyperstar, stars on a Hyperstar in the front, and camera stuck on the front of that, and it's all running on an AM5 strain wave mount and my spare no expense cinder block pier that's sitting out in my yard. So, and I'm on a table behind here talking to you. So that is what we are using tonight. Good evening, Daryl. Good evening, and thanks for stopping in. So this is the setup for tonight. Tonight we're using the narrowband filter, an IDAS-NBZ filter. So we are going to see some different nebulae tonight. Now let me get this window again resized so that you guys are able to see. Where am I? Yes. So you guys are able to see the whole screen. There it is. Something like that. And we'll do the same thing for our SharpCap, where we are going to capture our images. Alright, and something like that. Alright, so we're on Capella, which is what I used to do my my focusing on, and so tonight we're just going to actually start with what's right next door here, the Flaming Star Nebula, which is a beautiful little, actually not all that little, it's a decent sized little asterism here, and let me get up a little bit higher so we get more of it in the picture. Yeah, something like that will probably be about right. This is the brightest part, but okay, let's zip on over to that. Oops, I forgot to hold on a second. Well, I can get this started at least. Got to take my headset off to put the microphone over. Okay, and I'm also going to need to not forget to do the that's already gone. Not forget to do the flat. Gotta have my flat in here. I think it is the one on the 5th. Well, we'll find out soon enough anyway. And let's get this out of the way. Alright. Get my microphone up here so you guys can hear it for sure. And then we'll see where we are at here. Okay. Let's make sure the first sub is coming in well here. Again, for those just joining, Flaming Star Nebula will be our first nebula tonight. Alright. Wow. Everything is very, very blue. Why are we so blue? That's really weird. I'm not sure. Alright, well, I have a decent start to it anyway. Still don't think we got... yeah, we actually did pretty well on it. Good evening, Mike. Thanks for stopping in again. All right. Let's see how well we're doing here. I think that's about right. Okay, so Flaming Star Nebula. And it's not going to let me select the object. So let's get this up. I see 405 Flaming Star Nebula. Okay. It's an emission and reflection nebula in the constellation Auriga north of the celestial equator. Surrounding the bluish regular variable star AE Aurigae. It shines at a magnitude of +6 and nebula measures approximately, well, it's about 1,500 light years away from us. And is about 5 light years across. And the central star, they're saying, can be traced back to the Orion's belt area. So perhaps this star originated in Orion's belt. Maybe that's where it was born. Okay. Oh, I can't do that, can I? Because that makes it too big for you guys to see. But I can at least expand it till it fills this little window. Okay. Oh yeah, let's do this again. Boink. There, that's better. That's better. For some reason I got a very crazy this is still way too blue. Very crazy color balance there at first, after the first sub, but I think we're doing okay now. So again, 1,500 light years across, and I'm sorry, 1,500 light years away, and about 5 light years across in size. I don't know if that means just this part here or the whole thing here. I think it might just be this part here that's 5 light years across. Because it's pretty big. I guess I can put it up here for those who know to look up in the target name box. And SharpCap, I guess I could have it up there. Guess I could put on some background music. Have that going. water for my tea is probably boiling now, so I'm going to go check on that. Be right back while this continues to build up. Okay. I could probably darken that up a little bit. I should say brighten it up a little bit. Probably about right. I should maybe even a little more. Emission nebulas are pretty darn cool. They're usually mostly red in color. Red means they're hydrogen. And basically they are illuminated by nearby stars that basically ionize the gases in them such that they emit their own light. In this case, in the band of hydrogen. Probably hydrogen alpha. And when they emit their own light, they actually, even if the star went out, they'd continue to emit their light until their ionization died down. But unlike reflection nebula, which tend to be blue and are just reflecting starlight directly, these get irradiated, and their gas particles basically emit their own light. So they're called emission nebula. That's pretty much what we're going to be looking at tonight. For the most part. We'll see some that are different colors though. Later on tonight we'll probably go look at Thor's helmet, which is mostly greenish in color, but still an emission nebula. So, and the green means it's more oxygen. Greenish bluish means more oxygen in an emission nebula, which is different from the blue that's in a reflection nebula that's just reflecting the light of hot blue young stars that are around them. Well, Daryl and Mike, how are the weather in your parts of the world? We're having a pretty gorgeous night here after a pretty nice day. It was kind of in the mid-60s and it was warm and calm, and it's just really a beautiful night. Tomorrow's also supposed to be really nice, but they're saying starting late tomorrow afternoon, early in the evening, probably around sunset-ish, or a little after, the clouds are going to roll in, and we're in for a little bit of a stormy weekend. Maybe even some snowish, rainish stuff starting Saturday night, going through Monday, so we may even see some precipitation, possibly even some white stuff flying around, which we do get sometime out here. The snow will fly out here every now and again. It just usually doesn't stick. So we may see some flakes flying around here in the next couple days. Which is always kind of a fun treat. Hey, Kelly. Thanks for coming in. You said you'd be in tonight, so glad you're here. I assume you're well north of any of the fires. I'm wondering if we're going to see you out here at all this winter. Yes, we're all hoping for rain, Kelly. That's for sure. Wouldn't mind seeing some out here as well, especially out there though. That'll really help with the fires. Cold 38. Yeah, you're well north of the fires, and luckily for all of us north of the fires, it's been a northerly breeze, and all the smoke's been blowing off the coast. But still, it's been some nasty wind, and it's really fueled the flames, unfortunately. So I don't know if you were here. Yeah, thought about for March 13th. There's a full moon a-coming. Oh, cool. I mean, you're going to be out here. As I said, I was saying earlier, I don't know if you were here for that, but this is an emission nebula. It's about 1,500 light years away. So the light coming from this is about 1,500 years old, and it's about 5 light years across, which I think they probably mean the big bright part here, but I don't think they mean the whole thing. But that's a guess. I'm not exactly sure. Hoping to stay with Roger Tony. Yep. They got a nice little apartment. Yes, they do. Alright, while this continues to build, let's go. I should pull up my list here, which is right there. And we should highlight all and kick out. And this will be a list of all kinds of good targets for us to hit tonight, because they're all emission nebulae. Yeah, there's quite a few. Quite a few around. We can do fossil footprint next. It's a little small, but we can give it a try. I haven't done it in a long time. Actually, I think we'll do California next. The biggest problem with California is that it is so small. It's too big. I can only get about half of it in my field of view. So we might have to do it in 2 parts, or just do half of it. We'll try and spend 15 or 20 minutes on each object tonight to give them just a little more time to cook. What this narrowband filter does is it basically cuts out 98% of the light. It allows two bands of the light spectrum to come through. Number one is hydrogen alpha, which is the red that we're seeing here, and another one is the oxygen 3. Which is also in emission nebulas, and so it cuts out everything else and just lets those 2 bands in. And so stars, of course, they're full spectrum objects, so they contain those frequencies as well, which is why we can still see some of them. But it cuts down 98% of their light. So if we were looking at this with just my UVIR cut filter in, basically running unfiltered, you'd be able to see this nebula, but it would be drowned behind a much denser, brighter field of stars. And so, by knocking 98% of the light spectrum down, it really reduces the size of all the stars and even makes the small ones disappear, making it seem like the nebula pops forward, when in reality all you're doing is cutting everything else back. So, because it's cutting down 98% of the light spectrum, it just takes a lot longer to get finished images than if we were not using it. But the results are pretty spectacular. Like I said, if we were doing this without a filter, it would we would still be able to see the nebula, but it would be very faint compared to the very dense star field that it rests in and behind. It's coming out pretty well. The California Nebula is another nice bright one. Unfortunately, with the orientation of my scope and camera, I can only see about either the top half or the bottom half at any given time. So I have to either take it in 2 passes or just do only half of it and be content with that. But how far away is Orion, if that's where the star was born? Well, the Orion Nebula, which is M42, I want to say it's about 4,000, might be 2,000. Let me look that up. Visible angular eye, blah 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 blah. It's 25 years light years across. Distance, radius, distance. Where is the distance? Distance about 1,400 light years. Okay, yeah, so it is about 1,400 light years away. And this is about the same thing. This is about 1,500 light years away. So they think this star, I believe this is the star they're talking about, originated in Orion's belt and kind of just cruised over here. And now it is basically irradiating this entire area of gas. And it's radiating it in the hydrogen alpha band, which makes it look nice and red. It makes it emit hydrogen alpha and makes it look all pretty like this. Thanks, Daryl. We'll go to 20 minutes here and then we'll go up and see the California Nebula, which is 1499 up here. Tell if I'm back yet or not. It looks like maybe I am, but I don't know. If you can hear me, let me know. Working on getting back here. In the meantime, okay, let me do that. And let me see if I can't. Okay, you're broadcasting, you're going. Okay. And all this is going to have to be all reset. Okay, good. Thanks, Daryl. I have no idea what happened. All of a sudden, the screen on my PC just went completely blank. Backlit black, so it was still on, but just displaying black, and I had to hard crash the machine to bring it back. So that was definitely bizarre. Alright, so now, well, I think I should be well, oh, but I still have this up. Okay. Alright, and this should be, yeah, okay. Alright, well I still have Flaming Star up, okay. So, that's there, and where did, oh, that's right, I crashed, so I lost all of that. So let's get those back. And then all this needs to be resized again. Okay. Now I was trying to get to California, which is going to be down here. No, whoa, right there. Okay. Yeah, see, so now this is going to be only part of the size of my my screen, so kind of need to take it sort of half at a time, more or less. Alright, well, let's move over there, and let's move over there, because we got a pretty good image of the Flaming Star there for a bit. This is getting very close to the meridian, so I'm going to have to be careful. You don't want to go across the meridian. Okay. Alright, that's going, that's going. Where is my... There is that. Okay, those two are the same size. I need this to be that same size, roughly. Okay. Well, that was bizarre. Anyway, if that happens again, hopefully this time you guys will know. Yeah, the machine was still running. The screen just went black and it became completely non-responsive. So I'm not sure what that was about. But maybe it ran out of power and didn't warn me. That would also be a new occurrence. Anyway, let's get our first image of the California Nebula up here. Okay. And it completely messes up the blue for some reason. I don't know why it does that on the first sub, but it seems to like to do that on the first sub. Usually straightens itself out later, but okay. Still a bit blue. Okay. Boy, why are you doing that? That is just wacky. There we go. Just drag it down manually, and that should be hopefully Anyway, if we could see the whole nebula, you would see that it would look shaped sort of like the state of California. But this yellow square is my field of view, so we can really only kind of do one half of it or so at a time. And the whole thing is being irradiated by Menkib here. And so that star, Menkib, is the one that's actually irradiating all of it. Okay, let me... let's get the music started too. Okay, so let's look up NGC 1499. NGC space all copy 1499 go. California Nebula. It's an emission nebula located in the constellation Perseus. The name comes from its resemblance to the outline of the U.S. state of California in long exposure photographs. It's almost 2.5 degrees long in the sky, and because there's a very low surface brightness, it is extremely difficult to observe visually. It can be observed with a hydrogen alpha filter or a hydrogen beta filter under dark skies. It lies at a distance of about 1,000 light years from Earth. It fluoresces due to its excitation of the HP line in the nebula by nearby prodigiously energetic O7 star Xi Persei, also known as Menkib. California Nebula was discovered by E. Barnard in 1884. By coincidence, the California Nebula transits in the zenith in central California as the latitude matches the declination of the object. Ha! Alright. There we go. Now you got yourself a bit under control. You're still a little bit blue. Might be able to knock you down a notch or two, but not too bad. But there's a lot of nice rich texture in this. Hey Ronald, nice to see you. Thanks for coming in. Don't know if you were here for the excitement or not, but my primary PC crashed. Luckily it wasn't fatal, but yeah, I had to kind of scramble and get things back going here, but it seems like everything's fine now, so if it happens again, well, you guys will know why, but that was a bit exciting. If my camera was oriented 90 degrees in the other direction, I'd get more of this, but it's a pretty cool nebula. It's all being irradiated by this star here, which is this star here. Yeah. There was I don't know, bit of a hiccup. Can't really call it a disaster because it obviously didn't fatally cause any issues, but it certainly was interesting. Technology, can't live with it, can't live without it. But you know, this computer has actually been around. I've had this for a few years now, so I can't complain. I don't even know that it was the computer that did it, honestly. Don't really know. I'm assuming it was power, so I'm just gonna leave him plugged in and spend the rest of the night with him running on power rather than battery. Thousand light years away, so the light from this object is 1,000 years old. So we have no idea what it looks like right now. We can only see what it looked like 1,000 years ago, because the light takes so long to get here. Don't think we'll need to take as much time on this. It's a nice bright one. There are some other ones that we'll need to take more time on, but these first two bright ones aren't too bad. Flaming Star was actually pretty bright. I probably didn't need to spend as much time on it as I did, but I don't know, they're so pretty that it's hard to move off terribly fast. Can really start to see some of the interior structure now as I stretch it a little more. Don't want to get it too noisy, but need to brighten it up enough for you guys to be able to see that stuff. See, what are we gonna, should we get fossil footprint? It's a little bit behind this one. You might be able to get 15 minutes on that. I think we'll just do, this one is a good 10 on this. It's a really pretty one. Fossil footprint is a very small one. Footprint there, size is 9 by 6. It's a small guy. It's not going to be big like this. Probably pop over the meridian and catch things as they come across. I don't think we'd get 33. We can do Pac-Man. I think we've got enough objects in here. Lowers, yeah, there's a lot down here. I think we got enough to stay. We'll just stay on this side. We'll just stay on this side. So we'll finish this up this one more sub and go check out the fossil footprint really quickly. All right, 12 subs. That'll work for this nice bright one. Let's go look at fossil footprint now. Just pop real quick over there. This will be a much smaller, more modest one. But All right. Well, could probably about leave it there. All right, the fossil footprint, or NGC 1491. Let's see. NGC 1491. It's an emission bright nebula. This one is almost 10,000 light years away. So this one's quite a bit further away than California. It gets its deep red coloration due to the many massive stars embedded within it, producing large amounts of ultraviolet radiation and ionizing the hydrogen gas that makes up the nebula. That's one reason why this is much smaller than what we've been looking at so far. It's a lot further away. Yeah, there we are. Fossil footprint. All right, let's see. Back you off a bit. Balance your colors out. Yeah, you're gonna go crazy with the blue again, aren't you? For whatever reason, you like going nutty with the blue. I think that's the NBZ. I think it's my filter that does that. It creates a blue hue. Whether it blue shifts. I'm actually using the filter in a much faster optical system than it was probably designed for, and so it has a bluing effect. But after the first few subs, it tends to calm itself down a little bit. Back over here. Yeah, not nearly as spectacular as California or the Flaming Star was. But certainly a bit more modest. But at 10 times the distance of the California Nebula. Guess we shouldn't be terribly surprised. This is one of those that'll take a few more minutes. Hey, Michael. How did your ARP hunting go? Thanks for stopping by. We're going to be doing lots of emission nebula tonight with our NBZ filter. A nice hot drink is wonderful when you're out in the cold. Thanks for the thumbs up, whoever has given them to me. Appreciate you clicking on that, giving me a little YouTube love. Never hurts. Always like to see the thumbs up. Is it 99 and managed 3? Well, there you go. Some nights. That's a good deal, you know. Fossil footprint. It's interesting when nowadays we're imaging these objects with far more advanced technology than even the professional astronomers in huge observatories had 50 years ago, maybe even 30 years ago. So when they were naming these objects umpteen eons ago, they were not seeing anywhere near as much as we see now. So, I'd probably have to back the stretch way down here to be able to see what they were seeing. You know, they were probably seeing something much dimmer than what we can see now through a modern camera. So, it, you know, makes you wonder, no, so why did they call this a fossil footprint? Was it the whole thing, or was it just this part of it that they saw? You know, when they were staring at it all those eons ago. See if we can back it off maybe a little bit more. See if we can pick out any. See, I think there are actually little toes in here. Gotta be careful how much I back it off though, or I'll make it too dark for you guys. There's about a 30 or so second delay between changes I make and what you guys are seeing. So I'm monitoring the broadcast with a second computer, but I have to wait to see. Kind of looks more like a chicken foot to me. We've got a short toe there, and a couple of toes there, and I don't know. What do you think? Fossil footprint. I'm assuming this bright part was what they saw back then, and they didn't see all the extended nebulosity that we can see now with our modern cameras and telescopes. So, I don't know. Anybody see a footprint in there? I mean, they could have been considering the whole thing and not just this bright part in the middle. No. Don't know. I just know that now we can see a whole lot more than they ever could. Well, there we go. And the colors back into a bit more reality. That might be a little bit too much. Well, I'll see what it looks like for you guys. See if that's a little too harsh on the stretch. See, we're seeing some other wispiness out around. Even some very faint stuff out here that if we took a lot more time on, we could probably bring in, but you know, it's unlikely they saw a lot of this extended nebulosity that we can see today when they were visually observing. It's an interesting little streak in here. Looks like it's a lot lighter. It could be an area of oxygen. It's just lightens up a little bit, not quite so red with the hydrogen. Same thing for this. This could be a cluster of stars. I wonder if this is a star forming region. Yeah, 200-inch. Yeah, you can be in the neighborhood for, you know, what fraction of the price? And from where you're shooting, how's your, you know, how dark, what Bortle are your skies? Do your skies compare well with his? Yeah, you spend more time, it does definitely get pretty. Hey, Michael. Boy, there's a lot of Michaels on tonight. Mike, Michael, and Michael. Actually, I think there might even be a fourth Michael. A whole lot of Michaels. Thanks for being here, Ron, Kelly, and Daryl. Having some non-mics here. I guess I should include myself. Even I have injected myself into the chat now because of my crash earlier. Bortle 4, well, that's not too bad. I wonder if I can do as good as he did with my Bortle 2.5. So this is about 10,000 light years away. So light's traveling a long way to get here. So it's not one of the brighter ones that we're going to look at tonight, but a lot of interesting stuff in here. A lot of dark patches in here that are pretty cool. This is the fossil footprint, or NGC 1491. And we are just about to cross the meridian, so this is perfect timing. I'm going to finish this sub and we're going to have to move off because I'm about to hit the meridian. But yeah, this is the fossil footprint, which is a small, distant one, but still pretty cool. Alright, let's move off. Okay, we did Flaming Star. Spin this baby around. So we did Flaming Star. Is this spaghetti that I'm... Yeah, the spaghetti. That one is really faint. That one is really faint. Let's go do the jellyfish next. I can't see which one this is. Let's make sure I'm not leaving any. We can do the jellyfish in a bit. Well, I think we got time. That's 42. That's the Alnitak region. Those are both interesting to do with. Is there anything else in there? No, I don't think so. Spaghetti is just—it's really big and really really faint. So. Let's go ahead and do the jellyfish. Jellyfish is a good one. Okay, and what I want to do is make sure I get it actually a little bit higher than that, so I get all the bottom part. Yeah, that should be about right. Okay, let's go do that. Yeah, Mount's just about half an inch away from the pier, so great time to get away from the meridian. Don't need to be colliding with the meridian or the pier or any of it. Okay, let's plate solve that into the middle. I always, you know, per our conversation in the thread, I always use one. I never use anything other than one. So, yeah. All right, let's get started on it. I like lots of contrast. So, yeah. I mean, I suppose I could, while we're all here, I could play with a couple of different ones. But I like the ones that the one that has the highest level of contrast, and that is the yeah. See, now I can't select the jellyfish again. One thing I don't like about Stellarium. Okay, which is, it doesn't have an NGC number. Isn't that interesting? I see 443. I see 443, supernova remnant. Okay. It's a supernova remnant in the constellation of Gemini. On the plane of the sky, it is located near the star Eta Geronii. Its distance is roughly 5,000 light years from Earth. There we are. Hey, Fantasy. Yeah, and you're going to go stupid on the blue again, so we'll have to yank you back. Alright, we'll do something like that for the moment. And you're still a little too blue. Drag you back a little more. That's probably good for the first sub. We'll adjust as we go along. Okay, yeah, see, so I'm always in mode 1. We'll wait till we get a few subs on here. We'll try playing with it a bit. Yeah, just got to get off this curve a little bit. And I still got to go down with the blue. And stretch it a little bit more. Got a little bit of a breeze picking up in the moment. You might be able to hear it in my mic. Supernova remnant 5,000 light years away. Oh, you know what? Oh, I didn't put my flat back. That's why. Okay. Darn. I didn't put my... That's why I'm getting so bright in the middle. It's, I didn't put my flat back. Dope. Okay. So, unfortunately, we got to start over again. But it'll look a lot better. Yeah, I definitely have a little bit of a southerly breeze picking up here. Back that blue off again. Okay, I guess we can get back to our info here. So it's roughly 5,000 light years away from us. It may be the remnants of a supernova that occurred 30 to 35,000 years ago. The same supernova event likely created the neutron star. The collapsed remnant of the stellar core. IC443 is one of the best studied cases of supernova remnants interacting with surrounding molecular clouds. Yeah, so there's obviously more stuff here, and so the supernova remnant is interacting with all the other stuff that's here. And so I guess they've studied on it quite a bit. I guess we can kind of zoom in and look at this a little better. We don't have very many subs yet, so it might be a little grainy, but they'll fill in over time. It looks like it's about 70 light years across. Boy, one star creates an explosion so big that 30,000 years later it's 70 light years across, which is inconceivably massive. stage is still uncertain. There is some agreement that the progenitor supernova happened between 3,000 and 30,000 years ago. Rishon Chandra and XMM Newton observations identified a Plarion nebula close to the remnant southern rim. Location in the star-forming region. So 70 light years across, about 5,000 light years away. See how that looks with those adjustments. It's not too bad. Obviously the top of the shell looks bigger and brighter. Bottom part, but still it all kind of looks, and you can probably start to see that some of this is not all red. Most of it is red, but you can probably see along the edges here, and it'll brighten up as we take more subs in, but there's bluish green just around the very fringes down here, and even a little bit up here on the top. Almost makes it look like the Veil Nebula. So that's just a little bit of hydrogen around. Probably most of this lighter area is hydrogen as well. Excuse me, oxygen. Lighter area is oxygen. The red is hydrogen. And so this is just, there's some areas of interesting stuff here. I've a question is signed up for NSN, but not sure how to search for live rooms. Well, when you go to, well, let me see. I think Dawn was on earlier, so why don't I just pull it up here. Doink. Okay, so you're on Night Skies Network, and see right here there is a glowing blue button. And so that is an observer. If there's no blue buttons, that means nobody, an observer, a broadcaster. If there's no blue buttons, then that means there's nobody broadcasting at the moment. But usually there's one or two or three or even more. Sometimes there's usually at least 2 or 3 of us broadcasting. Don is in Pennsylvania, so he usually starts a bit early. And so you just click on the blue link, the blue button, and you will go into his broadcast, and it'll ask you, if you want to connect to just listen, or you want to talk on the microphone or whatever, and you can decide that, or you can just click the X and it'll just, you won't hear or see anything. You won't hear anything or be able to use a microphone. It'll give you no audio at all. And then you just go in and you get to see what he is doing in there, and where am I? Here I am. You get to see what he's looking at, and there's an area for chat, so you can chat to him as well, just like you're chatting with me here. And you do not need to sign up to do that. You can just, anybody can just click on a blue button from the home page and go in and, or at least I think that's the case. I know you have to sign up to be a broadcaster, certainly. I don't think you have to sign up, actually make an account to just go in and be an observer. Just go in and look. But I could be wrong about that. It's been a long time since I signed up. But I don't think you do have to go in. But anyway, hopefully, let me know if that doesn't answer your question. Happy to answer more questions for you if you want. Alright, we can kick this this up a little bit. Yeah, but usually there's at least two or three of us broadcasting, but some nights there's nobody. You know, coast to coast, we're having bad weather or just schedules don't mesh or whatever. So, but usually there's at least somebody early on. And then, you know, tonight if I wasn't here, I'd be over there. So David will probably be on a bit later. He's in the Bay Area. He and I are usually the West Coast broadcasters. But yeah, just go to that home page, and if there's a blue button pulsing, go click on one and see what they got going on. And if you don't like that, get out of that and go to another one. Different people are broadcasting different objects, so you get to just have your pick. Yeah, you were on the broadcast page. Yeah, you do have to have obviously an account to broadcast. You have to have permission and be allowed an account, etc. And but not to be an observer. You can just go in and look and listen and even talk without, I think, without even a login. So yeah, go in and check it out. Smoke from the LA fires affecting me? No, it's not, Michael. Because the breezes, the wicked winds that have been causing this are all northerly Arctic cold wind, and so it's, you know, all those fires are well south of me, so it's all blowing the smoke offshore the other direction. So no, it hasn't touched us at all. We've just been under the cold Arctic winds, but it hasn't really been affecting us much. Okay, you know, I never changed this, did I? No. Jellyfish. Alright, so now I promised that I would play around with the... So if we go to the stretch modes, you can see what we're doing now there. If I go to number 2 stretch mode, yeah, it just gets... So number 2 stretch mode, if I go back and forth, it just gets less contrasty. And so then I end up having to shove this in further to do what I want. And the more you go up, the less contrasty they get, because the curve just gets less and less aggressive as you go up in the stretch modes. So yeah, you can see that by the time I get to 7, it's like completely washed out. So I like a lot of contrast, so I just pretty much stick with 1. And sometimes that means I need to you know, I need to back off on the stretch a little bit if I get, well, you know, and so sometimes I get the blacks a little too clipped, but it yeah, it really works for me to just leave it on 1 and just have a lot of contrast. Let's see, we can probably push this a little bit more right now. See how that looks. And so, yeah, I just really like a lot of contrast. So that's just how I roll. So I like the most aggressive curve. Now I think you can really start to see some of that, the blue-green around the edges down here. Zoom in a little bit more on that. There you can see the wispy blue-green that's down here. Got it stretched pretty hard, so yeah, doesn't matter. I got it stretched pretty hard, so it's a little bit grainy, but yeah, there's just a lot of the oxygen down here. Yes, exactly, Michael. Yeah, you basically, I would have to adjust the histogram levels to get back to where I wanted to be by basically stretching it harder to get the contrast back, to get to the same place. By using the most aggressive contrasty stretch mode, I just don't have to stretch it quite so hard. So anyway, I just feel like it gives me more control over the contrast with the lower levels than with the higher stretch modes. I'm now using it to find faint details in the noise during a capture. Yeah, which I would do just by increasing the stretch. But if I get enough data, I can end at SM1. Yeah, it does get a little grainy. You know, as you can see here, it's a little bit grainy because I'm zoomed in and I'm stretched pretty hard, but yeah, there's a lot to see in here. Oh, definitely getting more of a breeze than they thought we were going to. It was nice and calm earlier. Well, hopefully it'll just go away again pretty soon. Yeah, you can definitely see the blue-green wispy oxygen going on in there. Go away, breeze. Lots of wispy little tendrils in here. The lighter stuff is more oxygen-ish. The red is more hydrogen-ish, so quite a mixture of stuff in here. But very wispy. Thanks for stopping in, Michael. Have a great night. I'll see you next time. Hey, Jim. Have I done a lunar or planet? No, no, I have never used the planetary stacking, actually. I am a DSO guy, not an SSO guy, as in solar system objects. So, I have never used a planetary stacker. Not even once. I probably should. I should probably get the thing out and... Well, I think what I'm going to do is... I've really been having a lot of fun with the Hyperstar on this thing. But I think eventually I'm going to have to break down and take it off and put the secondary mirror back in and pop my 6.3 reducer on there and do some other things, like maybe do some of the moon and maybe do a planet or two. Although those would be even better at f10. But yeah, I probably should do that. Take off some of the take off the Hyperstar and do some longer focal length stuff. And at that point, it would become more interesting to me, obviously, to do that. But in the meantime, I have not used the planetary stacking even once. So just have so much fun doing DSOs, especially since I got the Hyperstar at C8, and I just have never done the planetary thing. But I know, I mean, I have friends who certainly do it, and it's a very cool thing. If you do the solar system objects, it's a very cool thing. Anyway, so the jellyfish. We've taken our 20 minutes on this. Again, that blue-green really came in nice down here. So that's pretty cool. Supernova remnant, approximately 30,000 years old. 5,000 light years away. Uh-oh, wrong button. I hate it when I hit the... Not there. There. Okay. Yeah, I guess we could do... I guess we could do the monkey head. It's right here next to us, so why would we not do that? Why would we not do that? Thank you, Mr. Jellyfish. It will also be a little bit brighter than this. So, alright, let's go over and do the monkey head. Actually, there is a reason to not quite do the monkey head yet. Because we've got other things that are approaching. Yeah, let's go ahead and do 42 over here. Let's go ahead and do it. We won't need to spend much time on these. These are big, bright objects, and so we won't have to spend much time on them. So let's go ahead over and do the big shiny ones. Why not? Before they get too close to the horizon. I mean the meridian. Get in there, you. Alright, and now we will plate solve you there. Pop you right up into the middle. And we should have Running Man in here as well. So... and we will not need to have as much stretch on this, certainly. Yay, the breeze stopped. Yay, yay, yay. Hopefully it'll stay stopped. Makes it a lot colder when there's a breeze on you. Oh, good night, Michael. You have a great night, and I will see you next time. Thanks for being here. Alright, first sub. Coming in. Yeah, those curves look pretty good actually, so let's just go ahead and leave it right there. And this object is a challenge to image. There is a, oh yeah, and here's another thing that happens with this object. There are satellites bombing right through all the time. So, yeah. But anyway, the challenge with this object is it is a hugely contrasty object. The middle is blazingly bright, and the outsides are very wispy and fine and faint. So it is a... You basically have to pick your battles. You have to... so you've got two geostationary satellites going right through the middle of the thing. Uh-oh, where'd it go? Down there. You can get either one or the other, and you can't do both. Most of the great astrophotography that you see of this region is basically done by taking exposures like this, high gain exposures with lots of time to get all the faint wispy stuff, and then they superimpose it over captures with a lot less time that give you the unblown out core. So they usually put together a couple of different patched together different photographs, one taken at a much higher gain and or exposure level than the other. And so it's very tough to get this. If I were to back way off on this, see, the core is still pretty blown out. Even when you back way off on it, the core is still so blown out. But then, of course, you lose all of the outside stuff. I mean, the Running Man has almost completely disappeared. So, but it keeps the core from getting blown out. And so then when you bring it back, because you want to see all that cool outside wispy stuff, then the core just gets completely blown out. And seeing the stars in the middle, the trapezium and whatnot, the stars at the core is almost pretty much pointless if you're going to see anything on the outside. But you see, when you stretch it really well, then you can see all kinds of great wispy nebulosity and depth and texture and all that stuff. But you know, then the inner part is just completely blown away. So we'll get a few more subs in here, and then we'll actually, what I think I'm going to do is I'm going to clear this to get rid of those stupid satellites. We'll start again, hopefully staying fairly satellite free, but this is a very challenging area. My latitude is such that the geostationary satellites go right through the Orion area, so it's very tough to keep satellites out of the images. Yeah, and I'm not going to be able to I think it's probably going to be about right. Yeah, we'll give it a couple of more subs and see how it comes in, and we'll balance the colors off a little bit better. Seems to be a little too red, not enough blue at the moment, but until I get a few subs in. It's kind of hard to balance that off. So basically, these are the Running Man, and the M42 is basically the top 2 stars of Orion's belt. Excuse me, Orion's sword, which is kind of these 3 quote-unquote stars. Well, they're not really stars. Running Man is the top one, and then M42, the Great Orion Nebula, is the second one, and then the Coal Car cluster down here is the third, which is kind of this here. So this is sort of all 3, and when you back off on the stretch, you can they sort of separate a lot better. You can sort of see 1, 2, 3 there. They separate a little bit better, but obviously in the sky they separate much better again. So this is basically Orion's sword that we're looking at. Yeah, see, we've got another geostationary already started to come through. Just unavoidable. Absolutely unavoidable. Yep, M42 and 43. That's what they are. Looks like I got a few more thumbs up. Thanks for the thumbs up, guys. Appreciate it. Nice getting the YouTube love. But these are, so as well, actually earlier, these are 1,400 light years away. The Orion, these things that we're looking at are basically 1,400 light years away. This is a very large star-forming region. Actually, the entirety of Orion is a star-forming region. So lots of stars being born here. And the Great Orion Nebula is a stellar nursery, so which is why the core is so bright, because there's a bunch of bright, young, hot stars being born in there. So so it's just it's kind of an exciting area. Lots going on there. It's just, and it's pretty for us to see because it's so close to us at only about 1,400 light years away, and so it's just really neat to look at. What are your positive and negative comments about the program you're using? So Brian asks the positive and negative comments. I don't have very many negative comments. I've used SharpCap for many years. If you're doing EAA, electronically assisted astronomy, I think it is the best piece of software out there, bar none. You can do astronomy with Nina as well, but that's more geared toward astrophotography and not quite so much EAA, which is sort of intended more as live viewing. EAA is, and so you know, I've used it to do my EAA for a long time, and it is the best piece of software out there for this purpose. It does cost money, whereas Nina is open source and free. And you can do a lot of the stuff. The lines between Nina and SharpCap have blurred greatly in the last few years, just as the lines between EAA and AP have blurred a lot in the last few years. You know, what is astrophotography? What is EAA? You know, I mean, I call this EAA, but when I'm sitting on an object for 20 minutes taking 60-second captures and stacking them, is that EAA? Is that AP? I don't know. So the lines are blurred, but But, why did that do that? Been having some weird stuff going on with this computer tonight. Anyway. So, and I've already crashed once, in fact, tonight, so if I disappear again, well, it may just be my computer crashed again. It's been acting up a little bit tonight for some reason. So, you know, Robin Glover, who is the man who creates the software, is basically his full-time job now, and he does a great job with it. He's very responsive and puts in a lot of features. He listens to his user community, very active forum on the site. Good night, Ron. Thanks for being here. Oh, an 0600 road trip, huh? Well, have a great time, drive safe, and I'll see you next time. It's a very powerful piece of software, you know, and so as a result there's a lot to learn. The manual's pretty thick, so there's a lot to learn with it. So, you know, it's complex, but that's not really a downside. That's just the nature of having a powerful piece of having a powerful tool. So, you know, it's I'm going to stretch this some more just to get some more of that outer wispiness, even though it's going to blow out the core more. But let you guys see a bit more of this detail. But yeah, I really like it. It is the best thing for what I do. If you're more interested in astrophotography, I would probably look at Nina more than this. But if your goal is to just, you know, be out and do EAA and stack some subs and kind of look at things quote unquote live, this is the best software for it. And you can't do any better than this. So he does a great job with it. Now and again there'll be he does basically weekly updates with it. So sometimes a bug will show up, and you know, our user community will usually find it within a day or two of using it. It'll be found and reported on the website. And oftentimes he'll do, you know, a quick re-release just to fix it. So really responsive in that way. But you know, in terms of software and the developers, he's pretty great, and the software is pretty great. So I may sound like I'm a bit biased, but it really is great stuff. Again, I'm going to kind of blow this thing out to see the outer wispy parts of it better, but yeah, this camera is really good for doing small dim stuff. When it comes to bright stuff, it doesn't. It just tends to kind of get all blown out and whatnot. But you can kind of see the nice wispy, darker wispy tendrils that are up in here. Just kind of cool looking. Really is cool looking. And Running Man over here, of course. And the core completely blown out. The core completely blown out. Anyway, we don't need to spend a whole lot more time on this, but I figured we'd do it before it would go across the meridian. We can also go to and do this one here. Go do the Alnitak region real quick. Enhancements, I am using a minor amount of noise reduction, color noise reduction, just a little bit, and a little bit, again, very small amount of unsharp mask in the luminous channel. So, pretty low amounts of each, but yeah, a little of each. Okay, one last look, and we'll go. That's kind of cool. I never really noticed those up here before. That's really nice. Ha! Alright. And it's too blown out, but whatever. I still like it. Alright, now let's go up to the lump star and get the Alnitak region. Okay, and in fact, let's go and just pop this one. Come on, thank you. There we go, a little bit better. Centered, alright. And we'll just jump right into it. So this will get us both the Horsehead Nebula and the Flame Nebula. The Flame Nebula is not going to be its nice light tannish yellow that it normally is. When I do this with the this actually works a lot better when I do it with the UVIR only, UVIR cut filter only. This is better done full spectrum because you get more of a contrast between the Horsehead and the Flame. But it's still a very, very cool object to do. So while we're here, we'll just pop a quick look at it. Again, nice bright things, so it won't take us long to see it. Yeah, see, the Flame is more of a reddish, a ruddy reddish color. This is gonna crank the blue in it. Yep, just completely obliterate the dang blue. Come on now. That's not what I wanted. Still too much. Alright, well, that's a decent start. But there we are with the Horsehead and the Flame. And this here is Alnitak, which is the very left-hand star of Orion's belt. So that big bright one there is the very left-hand star of the 3 stars of Orion's belt. Alnitak, Alnilam, and Mintaka. And these are just some nebulae that are around it. And that Alnitak, the big, bright, blazing, young blue star there, is irradiating. Its ultraviolet light is just causing the hydrogen in the nebulae to emit light. And obviously the Horsehead is a dark nebula, blocking the light of the emission nebula behind it. And the wispiness in the Flame is also dark nebula. It's blocking the light of the Flame nebula behind it. So, just a very pretty area. The Flame is usually not so red. It's when you look at it natural, broadband, it's much more of a yellowish tan. It makes a really nice contrast with the blue of Alnitak and the surrounding stars and the lump star, which is this wispy star that has reflection nebula in it. It's all blue. This is usually a tannish yellow. And this is red. It's like a flag or something. It's like some really, really neat colors. So. Stretch this a bit more. Brighten it up a little. Okay, I think we'll do about one more sub on this, and then we'll head off to our next object. Okay, we'll go back to our monkey head now. Alright. Whoa. That was different. Okay. Back to our monkey head now. You see 2175. Embedded in a diffusion nebula. It was discovered by Giovanni Battista Odierna before 1654 and independently discovered by Carl Christian Bruns in 1857. And you see 2175 is at a distance of about 6,400 light years. The nebula surrounding it is Sharpless 252 and is sometimes called the Monkey Head Nebula due to its appearance. Okay. Yeah, way too high for whatever reason. You just get way too high. Alright, that's a little bit better. I still need to get you blacks unclipped a little here. There we go. Alright, you can see he's looking downward right now, but you can kind of see why they call him the monkey head. There's some equivocation in the use of the identifiers. Yeah, it's unclear as to whether they're referring to the star cluster or the nebula itself. Anyway, it's about 6,350 light years away. And, doesn't mention what the size is, but Gonna zoom in here a little bit. Let that get a few frames on. stretched it a little bit too much there. Kind of lose some of it. You stretch it too much. Dim it down just a little bit. Kind of a cool deal. Alright, what's next? I think we'll do lowers next. Lowers is the next one on the chain here. Yeah. Lowers, which is a sharpless object. Okay, let's do it. Good night, monkey head. Let's go get lowers. This one will be a bit of a dimmer one than certainly the last few we've looked at. I probably don't even need to plate solve that. Yeah, it's right there already. Didn't really need to do anything with that one. Such a small move. Alright. Let's see, was it 261 I said? Yeah. I don't know if we're going to have a write-up on that, but we'll try it. Sharp 261. No. Well, let's try that. SH 261. Nope. I have a 264, but I don't have a write-up on this one. I wonder what Stellarium say. Size, set, ROS. No, it doesn't say what. Doesn't say how far away or how big or anything like that. That's a pretty cool object, though. It's not bad for a start. If I do this, is the blue gonna go crazy? Of course it is. Why wouldn't it? Well, that's okay for a start. I think what we're going to do is we're going to do this one, and then I'm going to do, wow, it's Thor's down here. I'm going to do Thor's helmet. I haven't done Thor's helmet in a while. Is that 2177? Oh, I think it's down here more. I have not done Thor's in a while. Oh, there it is. Okay, yeah. Right next to Sirius. Which would be plenty high on this. Yeah. Thor's is in a good place, so I think I will spend a little time on this, and then we'll go do Thor's helmet. And that will be the last one for tonight. Sub in here. And we'll adjust on the third sub. There we go. Yeah, it's not too bad. I'll give that a shot. Hey Mike, welcome back. This would be Lowers Nebula. Oh, I've already moved on from it. Do I have, which is Sharpless 261, if you're going to look in Stellarium. The star cluster itself actually does have an NGC number. Oh, that's not the right key. There. NGC 23. Oh, no, that's wrong too. Where is it? Huh. It's 261 or LBN 863. So it's right in Orion's arm, basically. There's the top part of Orion. It's right in Orion's arm. Thing I do not like about Stellarium. Can't select objects. Only stars. Some of the time, most of the time. Anyway. Yeah, I'm glad you came back. I was able to hard crash my computer and come back afterwards. I don't know what happened. My screen just went black. Backlit black, so it was still on. It was like the screen went dead. It just went black and I couldn't do anything. I couldn't get it back. It was just completely frozen. So I had to hard crash it and bring it back and slowly get all the software re-going again. But the broadcast didn't drop. So it just kept going, and I eventually just came back in with all the software running. So ended up working out, and I was able to just keep going. Still have no clue what caused it. But I don't know. Don't know. Pretty fun nebula with some detail in it. Some wispiness and whatnot. Wikipedia doesn't have an entry on it, so I'm not sure how far away it is, but definitely a nebula being irradiated by a central star of some kind. Probably this star here is illuminating and irradiating all of it and causing it to emit its light. Is my audio cutting in and out? Looks like I'm pretty level here. My internet connection could be a little lousy. Let me know if it has improved at all. It looks okay here. At the moment, my internet looks okay here. But I have noticed at times my audio seems to do that. I don't know if it's the microphone or what it is, but okay. Well, Daryl says it's it sounds fine to him, so. Lower's Nebula, something I had wasn't even aware of for the last year or two. Didn't know that was even out there. Pretty cool, actually. It's a pretty cool emission nebula. Not one of the majors, one of the big sexy ones, certainly, but it's a nice nebula. It's got a nice inner part in here. Could even zoom in on that a little bit. Or the central star is really kind of illuminating all this stuff as it irradiates everything else. Kind of a cool little billowing nebula. Alright, lowers. Might as well let it finish that one last sub. And then we're moving on. Gonna do Thor's helmet. I like Thor's helmet. I don't do it very often, but it's one of my favorite objects. Just heard something weird from the scope. Well, we're already there, so. Okay, let's get a start. Found and saved, yeah. It's a cool one. Kind of an overlooked one. Let me go look at the scope real quick here, make sure nothing was amiss. There she is. Well, I guess I shouldn't say she. Thor's helmet, so probably more likely a he. Back off a little bit more. Yeah, there we go. 2359. Okay, an emission nebula in the constellation Canis Major. The nebula is approximately 12,000 light years away, so this is by far the furthest one I think we've seen all night. And it's 30 light years in size. Central star is the Wolf-Rayet star WR7, an extremely hot star thought to be in a brief pre-supernova stage of evolution. It is similar in nature to the Bubble Nebula, but interactions with a nearby large molecular cloud are thought to have contributed to the more complex shape and curved bow shock structure of Thor's helmet. The nebula has an overall bubble shape, but with complex filamentary structures. The nebula contains several hundred solar masses of ionized material, plus several thousand more of unionized gas. It's largely interstellar material swept up by the winds from the central star, although some material does appear to be encircled with the products of fusion and is likely to come directly from the star. The age estimates are somewhere in the 80 to 230,000 years. The nebula has been studied at radio and X-wave wavelengths, but it's still unclear whether it was produced at the class O main sequence stage development as a red supergiant, luminous blue variable, mainly as a Wolf-Rayet star. Cat 71 can't quite reach Thor's, huh? Not sure what that means. What does that mean that it can't reach? Is it too low on the horizon for you? Actually looks closer than I thought in telescope is 350 millimeters. Well, I'm only at 390, so you know, I don't have a whole lot more than you do. kind of fitting, I guess, that we're going to end on an emission nebula that has almost all oxygen in it, very little hydrogen. Almost everything we've seen tonight has been pretty red with lots of hydrogen, but this one's got lots of the blue-green oxygen in it. You can see the edges have a little bit of red, but lots of oxygen in it. Normally we've been looking at red nebulae with green-blue edges. This is the opposite, which is pretty cool. Good evening, Kevin. Yeah, there's a number of people sitting in chat. This is such a pretty nebula. Love the color of it. Alright, Thor's helmet. Very good. So this is where I wanted to end, but now suddenly I've got a burning desire to look at the dolphin. So I'm going to go over and look at the dolphin. This one I don't think is going to work very well without some significant time. This one is very, very faint. And really needs some time to get it right. In fact, probably more than 60 seconds. So in fact, what I might do is I might go to 1.5 minute. My 1.5 minute profile. We'll do 90-second subs on this and see if we can't. 90-second subs. Plate solve on it and just see how much of it we can even pick up. I have not tried this one yet with this setup. almost there. It is very faint. Very faint. I'm interested to see what a 90-second sub is going to do. I'm not using guiding, so I really can't go much beyond 90 seconds. So this is kind of our bonus object, and we'll see what we get out of it. This one really I should spend some serious time on. You know, at least 30 minutes, 45 minutes total time on it to see if I can really make it work. It's a very faint, wispy. It's beautiful, but it's a very faint, faint object. But we'll see what a few subs will do on it. We're having to wait a little extra time for them, but it's all right. This is probably gonna try. No, it didn't. Actually, it did pretty well. Okay. And you over there. And you way over in here. Yeah. Well, there it is. It's a pretty one. We might actually get some decentness out of it. We might actually see something decent from it, who knows. A little faint at the top, but it's alright. We'll see what a few subs we'll get. I really like this nebula. It reminds me a bit of the Veil Nebula. Just a smaller version. And very little red in it. But pretty cool. Again, no NGC number. Just a sharpless number. So Wikipedia actually does have something on this. It's a hydrogen 2 region, hydrogen beta region, even though it's all blue. Which is kind of interesting. Located in the center of the constellation Canis Major, composed of ionized hydrogen. It's about 8 degrees south of Sirius, the brightest star in the night sky. The nebula is bubble-like and surrounds a Wolf-Rayet star named EZ Canis Majoris. The star is in the brief pre-supernova phase of its stellar evolution. So, again, just like Thor's, It's the Wolf-Rayet star driving things, and it's in a pre-supernova phase. The nebula is about 4,500 light years away, although some sources indicate it may be up to 6,000 light years away. The nebula surrounds the Wolf-Rayet star EZ Canis Majoris, also designated EZ CMA or WR6. Its apparent magnitude varies from 6.7 to 6.9. Its spectral type indicates the star is very hot and luminous. EZ Canis Majoris is expected eventually to explode in a supernova, therefore subsuming the nebula. The nebula was formed about 70,000 years ago by the star, that central star, throwing off its outer hydrogen layers, revealing inner layers of heavier elements. Fast stellar winds blowing at 1,700 kilometers per second, 3.8 million miles per hour, that's moving, from the star create the bubble-shaped nebula as they sweep up slower-moving material from the earlier phase of the star's evolution. The hydrogen composing the nebula is ionized by the intense ultraviolet radiation from the star. The nebula is approximately 60 light years across. So, I'm assuming it's this one here. But we can try and confirm that with our annotation here. Yeah. 3165. Do they have a number on? Yeah, so this has got to be it. That's got to be it right there. Earthly colors, yeah. Even though it's hydrogen primarily, it looks blue. So, I'm not really sure why. But this is a very faint nebula. It really takes some serious integration time. I just want to see if I could get it. You know, we'd have to spend at least half an hour on this. To get it with any level of solidity, but this is encouraging. It is encouraging. Yeah. Yep, the dolphin's nose is definitely coming in there. Well, I guess I could stretch it even more. Probably be kind of grainy, but be able to see more out of it. Just needs more time. But it's definitely there. It's definitely filling in. And with several subs, it probably would fill in pretty nice. Some time. probably would also benefit from some longer sub-exposures, but I'm not even doing any guiding, so this is basically the AM5 running 90-second subs without any guiding, and doing pretty well. In my earlier testing, I was able to get up 90 and stars stay nice and round. At 120, things start to get a little elongated. So that's about the limit for the AM5, but still, 90 seconds unguided is pretty darn good. I'm certainly happy with that. Yes, Chris, this is 308. Yep. Thanks, Chris. Appreciate it. Thanks for being here. This is the best I've ever got it, but then, again, this is the first time I've ever shot it at f/19, so I've never had a scope this fast before. So even with the filter, it's 90-second subs are doing a good job pulling it in, so. Some more time than I'm going to take tonight. I might do 20 minutes. We'll see. It really needs at least half an hour, probably 45 minutes, or even an hour to get it to fill in well, but I just wanted to see how much of it I could get at 90 seconds. So I think it's looking pretty good, actually. Filling in better than I was able to get with my Newt at f3. So speed does make a difference. So as you can see, I had a sub that got ignored earlier. It ignored one of the subs, and it wasn't this last one, it was the one before that where the brightness went all of a sudden very low. And the reason for that is because I'm shooting low on my southern horizon, so I'm shooting through power wires. Basically, there's a telephone pole and wires behind me, so I'm only, what, 25 degrees off the yeah, so there's 10, 20, 25, less than 30 degrees off the horizon, so I've got a telephone pole right behind me with wires on it, and that's why we're that's why I dropped a sub. So my brightness filter knocked it out. As long as we don't make a habit of it. Yeah, so it's continuing to stack now. So I'll probably just do a couple of more here to get close to 20 minutes and call it a night. But I'm very happy with what it's getting. So I'll my next decent night, I'll probably get on Night Skies Network and broadcast over there and maybe spend an hour on it. You know, just chilling and watching it come in. See how well I can fill it in. But he's doing pretty well. Well, cool. That's 21 minutes. So I think I'm going to call it a night. And thanks everybody for being here. I really appreciate you guys hanging out with me here and watching. And if you're watching this tomorrow or next week or next month, thanks for sticking it out this far. So I appreciate you being here, and I will see you next time. Not sure when that's going to be yet. Tonight's kind of the last night, and we got some storms rolling in over through the weekend, and so it'll be probably middle next week before I can get on again, but we'll see. Yeah, thanks Fantasy for being here. Good to see you again. And yeah, I will see you guys a bit later on. In the meantime, have a great night.